My mic's coming through okay? Oh, I can hear it. Awesome. Thanks, everyone, for having me. Real quick show of hands, if someone wanted me to do this. How many of us are developers in this room? Okay, like 80, 90%? Probably 90%. And how many of us are like actively using LLMs for scraping in any capacity? Okay, got it. How about LLMs not as an agent for coding, but literally putting websites in the context of an LLM and getting data out? Okay, so that's kind of expected. I think that's where we're headed off today, so makes sense. Thanks, guys. So my name is Jerome. I work for a company called Diffbot. We structure the web using AI models that we've built. It's not all LLMs, although some part of it is LLMs these days, but we've been doing it for about 14 years. I want to start with a bit of an experiment, especially knowing the crowd that's here today. So this is a 100 by 100 grid of completely random numbers. Each cell has a number from 0 to 10,000. And we're going to extract them. We're going to take all 10,000 numbers. It kind of lives in the CSV format, so kind of what you see over here. But we're going to take all 10,000 numbers, and we're going to ask GPT-5 Mini, in this case, to turn it into JSON. This is pretty much the entire code for that. So it's really, really straightforward. Effectively, a CSV to JSON converter in the most, I guess you say, most environmentally unfriendly format. So how many people in this room think that the extraction will be accurate? Oh, actually, before we get there, I also wrote a verify script outside of this. And it's really simple because it's structured going in, structured going out. So we're just comparing cell by cell, row 1, column 1. Is this exactly the same as row 1, column 1 in the JSON? So knowing this, how many of us think that the accuracy will be more than 50%? 50%? Okay, cool. 80%? 100%. We got some believers. We got some believers. I love it. 100%. Crazy enough. 100%. And this didn't just happen once. It happened 4 times with 4 different completely random number sets. And I really didn't think it was going to go this way either. I was the 98% of you guys who thought that I was going to be writing a completely different presentation. But it ended up being 100%. And, you know, we're really talking about 30,000 tokens here. So when I was going into it and trying various things to trip it up, so for example, let's get some subset of the data and transpose it. So, you know, rows, columns, switching out. It's still 100% every single time. And I don't want this to be a pitch talk about GPT-5 Mini. I know it's great. It actually works with a bunch of the latest gen models. It's crazy. And so GPT-5 Mini, GPT-5, 2.5 Pro, 2.5 Flash, Grok 4, there's a little asterisk there because it did it after 18 minutes. I was about to just Control-C that. It was not looking like it was running. Relative to GPT-5 Mini, which is roughly 4 to 6 minutes. So that's decently fast. Now, the others down there, there's no bar because they are 0% accuracy because they either didn't validate the schema or they just didn't produce anything. I think Grok 3 was the only model that did produce something, and 100% of it was hallucinated. So that means anything. But that kind of gives you an idea as to how the models from the previous gen kind of compare to these latest gen models that were released basically June forwards, right? They're able to turn a 100 by 100 grid of numbers from CSV to JSON. And you know, the grid's a little bit arbitrary. I could have used 50 by 50. I could have used something smaller, and it worked with the previous gen models. But the point is, there is this difference between context that is supposedly 1 million tokens large that you can stuff into a model, and the 30,000 or so tokens that it can actually use to think with in this high capacity way using numerical tokens, which is really, really hard for it to do. So if I want to kind of work down that path, right, we've been building orchestration, self-healing agents. We've been building agentic coding, all these things to really try to manage the failure modes of LLMs when it comes to scraping. And here we are with an LLM that, when given 30,000 tokens of pure chaos, it can reproduce that entirely with 100% precision and recall. Can we take advantage of that? What if LLM scraping just worked? What if we just gave it the raw data, as raw as we want it to be, and it just gave us the data that we wanted? So I wanted to explore that. So today we've got 2 demos. They are 100% live on Archer guest Wi-Fi. So if it fails, it's their fault, and if it works, it's my fault. So demo number 1, we're going to start with automating some news signal workflows. So this is a real use case. This is a acquisition in the news, or what it would look like in the news, or an example of that. And you can tell because there's a title. It says Arc Browser Maker to be acquired. And if you read a little bit longer, you can see that 610 million in cash. That right there is how 99% of the world currently extracts acquisitions. They just read it, right? They read it, maybe from a Bloomberg terminal, maybe from a news headline, and then they write it down, they put it in some CSV somewhere, and they send it off to be processed. There are some ways to make this easier. There's NLP techniques, things like that, but it's not super accessible to most people, and it's hard, it's finicky. So can we build that scraper using GPT-5 Mini or these latest gen models? So here's what it's going to look like. We're going to get some news. We're going to filter it down to M&A articles. Forgot to put this in here, but we're also going to scope that down just a little bit. Actually, ignore that. We're going to get some news. We're going to filter M&A articles, and then we're going to extract the acquisitions as JSON. So what does that actually look like? We're going to get some M&A news from the diffbot knowledge graph. Now, granted, this is not straight HTML. This is articles that have already been pre-processed, so it's just the text. But you can do this with any article extractor these days. There's tons of these reader-type packages that you can pull just straight text from articles. And but yeah, we are pre-classifying them, so you can see the query on the very top, acquisitions, mergers, takeovers. We're already just using articles that are classified as acquisitions. But we just don't know what kind of acquisition. We don't know the exact details of that. So that's why we define a schema. Now, this is the magic of what's going on here. This is not totally unfamiliar with all of you, but this is a Pydantic schema. We're going to give it plenty of type hints to help the model kind of guess as to what we're talking about when we're saying acquiree or acquirer. You'll see that acquiree, the second to the bottom here, has this no need to clarify subsidiaries and parent, just the name. Sometimes that happens when it tries to pull things up. It's not a simple extraction, really, because if you look at something like sale currency, that's not always obvious, right? Like a dollar symbol is not always used to represent the USD. It's used for other various dollar symbols or currencies as well. So it needs to think a little, it needs to use a little bit of general knowledge to get there. So it's not as simple, or maybe it is simpler than a JSON to CSV converter for a bunch of random numbers, but this is a pretty challenging task. And our prompt, it's a little bit long. I've tested this a few times, so I've had to add a couple things here and there to guide it towards a very specific acquisition type. In this case, we're talking about majority acquisitions only, so more than 50%, things like that. And now we hope and pray. So let's switch over to the code here. And you don't really need to see any of this, but I'm going to reset this real quick, and then we're going to run this guy. All right, so while it runs, I'm going to give you a quick overview as to what's actually happening here. The code is the same. So let's see, right over here. Yeah, so you've got the Pydantic model and things like that. There is a little bit of a front end. So let me show you that.
Hey, brother, can you control ++ for us?
Oh, yeah. Oh. There you go. Actually, you know what? Don't worry about reading it because I've already shown the code. I think you'll be okay. I just want to show you the front end of this because this is where the magic will be shown. Okay, so it's already started doing some stuff here. But before we kind of get into more details here, I want to talk about how this front end is built. So all it is that code that I was using to declare the schema and pull the, I'm using Grok 4 here, so that's going to be a little bit slow. But let me pull this out. OpenAI GPT-5 Mini. I was doing some testing earlier. Okay, so it's going to pull the data out of the parser, and we're using client.chat.completions.parser because we're really enforcing that schema. We're not going to do this string to JSON conversion over here, although it does actually happen behind the scenes, but it won't return any of that if any of that doesn't validate the schema. And we're going to save it all into a JSON-L file. And that is all this front end is doing. It is just reading the JSON-L file, updating it every 5 seconds as it sees anything new. So you can see it's already finding the article that I mentioned earlier, Atlassian, the browser company, sale price of 610 million, USD currency, the date, and then the source we actually added in as a post-processing thing because we know the article URL. And this is all happening in real time. It takes about 20 seconds per article. Not every single article will have a valid acquisition. Sometimes they're mergers, but it's all happening in real time. And I want to say 100 or so times I've run this in testing, it's been exactly the same results, which is frightening to me, but also pretty exciting. But as this runs, I want to kind of give you an idea as to what it looks like with some of the previous gen models, or even some models today that were just released. So Qwen3 Next ADB, 80 billion parameter model, just released maybe 2 weeks ago. This is the data it comes up with. If you have a good eye, you can already see some issues, actually a lot of issues. In the Pydantic schema before, we had an option for the sale price to be null. And this is for the case for we just didn't mention what the sale price was. And it seems to sometimes obey this, sometimes not. You'll see that there's an NA sale price for the Sun Auto acquisition, but 0 otherwise if it can't find it. There's a currency in the bottom that's just called currency, and then sometimes it just uses the dollar symbol for currency. So there's no consistency here. I wouldn't recommend Qwen3 ADB for this task. Grok 4, I was doing some testing earlier, like I mentioned. Still having some issues. This is also a latest gen model, but not quite where we want it to be. Not able to detect the millions as opposed to an acquisition for $550. And then we've got GPT-5. This is pretty good, honestly. Like it's performing pretty much just like GPT-5 Mini. It's much slower. It's a large model. But it's got most of the acquisitions that I'm seeing when I run this feed with GPT-5 Mini, which is what you're seeing over here. But this is the expected result for a GPT-5 Mini. And honestly, everything here works. I've checked every single acquisition. It all comes through correctly. And all I did was send in article text, and I'm asking for JSON with the Pydantic schema. We slot back into here. OK, it's still running. So it's going to take a little bit of time here. But you get the idea. It's running in real time. It's returning this data just like we're seeing in this slide. If you like to check out the repo for yourself and actually rerun this and give it a shot, here's the QR code. I'll leave it up there for a second while I kind of talk track the next thing. So one small side or small downside to GPT-5 Mini. It's a little bit slow. Relative to the other models that we've tested, it's already pretty fast compared to GPT-5, Grok 4, but it's a little slow, 60 tokens per second. And when we're looking at actually per article, how it's analyzing every single article, not all of them will have acquisitions, so per article, 20 seconds of analysis each. So it's going to take a little bit to run through these, and it's okay for async applications like this acquisition feed, but there's not that many acquisitions happening per second in every single day. But if you have a need for faster, like much faster extraction needs, is there a way to really squeeze out the performance of LLM models today? Can we still run the same model of just stuffing it with something that the raw data that we want and the JSON that we're looking for from it? Turns out there is. So the fastest models today, at least that are accessible to my MacBook, is the open source GPTs that were just released, I think, a month ago. GPT OSS 20B at this crazy 7,000 tokens per second throughput. And this is running on Grok. So, if we're looking for fast inference, we're looking for providers like Grok and Cerebras. The other option is GPT OSS 120B, running at a crazy 17,000 tokens per second throughput on Cerebras. This is actually probably not something I've ever seen. I mean, it's like more like 1,500 tokens per second in reality. So I've done some testing already, so we're just going to stick with GPT OSS 20B. And we're going to try to build and clone builtwith.com. Hopefully nobody in builtwith.com is here today. All right, so how are we going to do this? Or why are we going to do this? Well, we're building this builtwith.com because it's actually a task that's a little bit hard for rules. That every site is a little bit different when trying to extract or list their subprocessors. That's actually how we're going to approach this. Is we're going to just scrape the subprocessors off of their DPAs. So the structure is going to be different from site to site, but it's really a pretty straightforward extraction task. You're just looking for names, maybe descriptions, maybe addresses. You can really give it what you want in the Pydantic schema. And we're okay if it misses one or two of these. It's not that important because we're just going to go through a lot of these anyway. So we're okay adding a whole lot more speed as long as it's still able to get like 99% of what we're talking about here. So that's going to be the path. We're going to get a URL, we're going to convert it to Markdown, and we're going to extract subprocessors. And this time we're going to use a diffbot API that turns a site into Markdown. It's similar to the article API, except that this one will return a little bit more formatting. And then we're going to define a schema, much simpler than the acquisition schema this time. Still a Pydantic schema. We're just going to ask for name, address, and description. And you can see that we're looking for a list there. And then we're going to prompt for subprocessors. Again, it's really, really simple. All of these are under 100 lines of code, and we're able to structure so much more than you'd expect. And yeah, finally, we're going to enforce GPT OSS 20B on Grok. And then we're going to pray. All right, so what port are we running this on? 4,000. Okay, got it. I'll zoom in a little bit so you can see the code. But it's the same idea again. We're talking Pydantic schema. We're just running it against Open Router and GPT OSS 20B off of Grok. We're getting the extracted data schema. This time, we are actually doing this live as opposed to saving it to a JSON-L file. And there's a basic front end that does that. So let's see what that looks like. So I've got some examples pulled up. We're going to start with Zeit, which is the article or the subprocessor list example you saw before. The page looks like this. So you see a lot of extra content here that we don't need. We're just going to, the LLM is just going to filter through all that, find this list of subprocessors, pull up the table, and generate structured data out of that. And so we're going to just start it right away and see where it goes. 7 seconds. So pretty fast. It's doing the whole, not just the LLM inference, by the way. It's rendering, it's fetching, rendering, extracting, and structuring this entire thing. Name, address, and description. So that's pretty incredible. Diffbot's DPA is much smaller, but still quite a lot of text. You'll notice that we actually list ours in paragraphs. So this is not a table. There's no structured format to that. I wrote a little piece of this, so there's not even any semantic labeling happening over on this side. But we'll give this a shot as well. And able to extract it in 5.75 seconds. So very, very usable for production speeds. Finally, we'll try for Stripe. And it's Stripe. There's a pretty huge page here that we're working with. "12 seconds. So in practice, I'm able to see somewhere between 2 to 10 seconds in reality. So 12 seconds, a little bit longer than I'd like to, but I promised a live demo, so here we are. So here's some screenshots of what I was able to pull up in terms of speed. So like 6 seconds, 4 seconds for Diffbot, and then I guess this one was Stripe. That's 5 seconds for some reason. It was really fast. So the LM inference is actually this level of speed. If we take out the rendering, the fetching, and all of that, this is actually what's happening when you're running pure LM inference, sub 2 to 3 second inference and pulling out the structured data, which is really, really impressive and totally usable in production. And as a sort of bonus, it's actually really cheap. 10 cents per million tokens. Each run of that page that you saw earlier was roughly 1/10 of a cent to 20th of a cent. So cheaper than your favorite residential proxy provider, probably. Once again, link to the repo if you'd like to try it out. If you get it faster, please let me know, because that would be really impressive. And I would love to deploy that as well. So what does this all mean? Like, what are we taking away here? I wrote these two demos because I think that LLMs are actually turning around. I initially started with this idea that maybe we weren't ready yet for LLMs to be handling this much structured output. And it turns out actually OpenRouter wasn't even ready for that, because I was running all of these tests on OpenRouter before, and it chokes delivering 30,000 tokens of structured output. So the infra around being able to generate structured data like this is still not even ready for this. But if you go directly to each LLM provider, it's able to actually deliver all 30,000 structured tokens of output from the 100 by 100 grid eval. So actually, it's possible today. All this structured data can be obtained from very, very raw input data. Granted, a little bit of cleanup here and there, but stuff that we know how to do. It's not totally impossible. We're moving towards a puck that is encouraging us to write schemas, not rules. And it's really quite possible to let kind of AI take the wheel from here on out. And I think we're going to start seeing that happening more and more often. So that's it. Just had a couple demos. Thanks so much.
Any questions, anyone? Please post them to Slido, but I think we have time for one or two. Yeah.
Hello. Thank you for the demo. It was just really great stuff. One quick question, just why your dates were on the same day? I don't think acquisitions were on September 7th for all of them.
Oh, yeah. So because we're pulling all this data off the Diffbot knowledge graph, I am specifically looking for a specific date, just so I can control the input data for that and see the same results every single time. But yeah, I mean, it could be from a bunch of different dates. In fact, with some of the larger models like GPT-5 or Grok 4, it's able to tell when the acquisitions closed on a totally different date, because they might have inked today or September 7th, but the transaction is going to close next year. And so it was reading all of that and putting it up there. So there is room for even better quality data up there if you really wanted to.
Yeah, I see. And another question, when you say that you don't need to define rules, what exactly do you mean? Because I think you need to give some rules to get your goal done.
You mean for the schemas?
Yes.
Yeah, so I think of rules as like XPaths and ways to basically tell exactly where to look for certain things. I think of schemas as really just a description, of the data that you want. And it's not totally unusual. We've probably done this quite a few times when we're asking for structured outputs from every LLM. But in this case, I'm asking it to do a lot more than just transform data. I'm asking it to look for the data. And I'm not giving it, if I scroll back to some of the acquisition schema, if you see, I'm not telling it where to look for any of these. I just tell it the data that I'm looking for, and it's just finding it. So don't consider that rules, but probably more so schemas.
Okay, got it. Thank you.
Yeah, thanks.